Okay, so today, as our plan goes, we're gonna talk about containers. So let's see what we have. So today we're talking about AWS containers and containers in general. So we have 10 stuff today to talk about. Well, these are a lot. Okay, so we're gonna give a brief introduction in general about Docker. And then we're going to talk about the key concepts. Then we're going to see a comparison between Docker and virtual machines. Then we're going to see what types of Docker we have in AWS. And then we're going to talk about launch types, load balancer, and auto-scaling integration. Then we're going to talk about data volumes with EFS, use cases, and some benefits. Okay, so these are kind of a lot, but let's go. So the first thing we're going to talk about is introduction. So let's see what kind of introduction we have. Okay, so AWS Container Service, it's going to make us contain our services in a much easier way. How so? Because you can focus on the things you need. And like, I need to show you this picture. Or let me go to AWS Container first. So AWS ECS, which is Elastic Container Services. And we can read about it. Even if we open docs or documentation that is related to AWS, we're gonna know a lot of information about it. But Elastic Container Service in AWS helps us manage our businesses and infrastructure using a container way. So of course, customers such as Samsung, GoDaddy, and Snap uses AWS containers to run their applications. This can give you a lot. So if we look at what kind of customers are using the AWS services, you're gonna understand how powerful service it is. So this is introduction about AWS containers in like a brief. So it's just a service in AWS for containers. We have multiple types of containers, and this is gonna help businesses run their application. And we're gonna see what does container and Docker mean, and you're gonna get the full picture of it. Okay, so we're going to talk about an introduction to Docker. So Docker is a platform that is designed to deploy, run application using something that's called containers. So I need to get a container. Let me try and find one. Okay, maybe this plus the things I use. Okay, so when you try and run a container, or when you try and deploy an application, let's say, there's a few applications that has, let me try and think of something. Okay. So let's say my application is built on Python. And, Python and many programming language with time have more benefits and have more stuff that older versions cannot have. Like maybe, let's say, built-in libraries or stuff like this. So let's just imagine we have an application, and this application only runs on new versions of programming language. So let's take Java, for instance. Okay. So we have this application that's running on Java. It's working on my computer, but it's not working on someone else's computer. So maybe the Q&A is trying to test, and they really don't care about like having their programming or their SDK up to date. So maybe you have Java 14. Maybe you have Java 14.0, and this is you, and QA has like maybe 12.0. So maybe your application that you have designed have some specification that can run on Java 14 and doesn't run on older versions. So containers help you with this kind of problem. So it kind of bundles up everything. يعني بيجمع كل الاشياء اللي احنا بدنا اياها, الruntime, the code, all the dependencies is gonna contain everything that we need to run the code, the runtime, the language, everything in a single container. So you have like this gift box, and then, or not a gift box, let me think. So I have a tools kit. So this is a tools kit or a building toolkit. Okay. So not shopping, not shop for a building toolkit. Okay. So let's say this is the building toolkit I need. All right, this is much better. Okay. So this has a few things that we can use. Okay, here it is. So this is my container or my toolkit. And then my friend Tim, let's say, so Tim wants to use this toolkit. So I just give it to him in this red container. Okay. So this container actually bundles everything of a toolkit that I need in one place. And when I want to give it to Tim to like use it, he only has to open this this container, and everything has everything in it. So this is a container. Okay. So Docker helps us with a lot of problems. One of them is this problem that we are having or handling, or the Java one. So this is gonna help us a lot, especially when you're developing. It's part of the DevOps. And yeah, so let's read. So it's gonna allow developers to package an application with all its parts, including libraries and other dependencies, and ship it out as a one package. So actually, containers came from a literally container. So if we open a container, an image, so this is the container. So it's gonna hold like everything. Not the IKEA one, though. This is a container. So as you can see here, this is the dock, a ship, and it has like small containers or boxes on it. So this ensures that the application will run no matter what the environment that we have, or regardless of any customized settings. So we only just need to package it up. So there's a few key concepts for containers. The first thing is called a container, which we have talked about. Then we have something that's called a Docker engine, an image, and a Docker file. So what's the difference between these four? These, of course, are used in Docker. If you're writing in Docker, you're gonna see this a lot. So container, as we said, it's a bundled up package. It has everything. It has the code, the runtime, the libraries, the settings. It's also lightweight, standalone, isolated, and executable. So you can execute it. And it's used to run a piece of software. So Docker Engine is the core component of Docker, which acts as a client server. So when you're talking to Docker, you're talking actually to a server. So this is Docker Engine. And with three main components, it has a server, it has a REST API, and a CLI. So a CLI is, when we have learned Linux, this is a CLI, and a server, we have known what's a server. It's a computer that serves clients. And the REST API, or application programming interface, we don't have to know that right now. We're going to talk about it maybe later on. So images are read-only templates. So if you take a screenshot or a picture, this is what you can use it over and over again. So this is a read-only template to create containers. And then images are built from a set of instructions written in Docker file. Okay, so images are written from Docker file. Now let's see what's Docker file. It's a text document, so .txt. It contains all commands a user needs or could call, and it assembles an image. So Docker file gives us the ability to build a read-only template, which is an image. And how we deal with them? We deal with them using Docker Engine. Okay. So quickly, let's see what's the difference between Docker and virtual machines. Of course, Docker are very close to virtual machines, as they both give us the same thing. So let's say if, okay, I need a program or a program that runs on, let's say, Java or anything, we can like launch it on a virtual machine and it can work. So let's see what's the difference. I want you to concentrate on the word lightweight, because this is a huge difference. So lightweight. Okay. So the first thing, architecture. So Docker runs on Docker engine, and this runs on a hypervisor. Even cloud runs on hypervisor. This shares the operating system, so this is this where it gives us the lightweight resource, and this includes guest operating system and virtual hardware. Okay, so then in Docker we're gonna have lower resource usage, and this is higher resource usage. Wait, I have a comment. It's very contested in dev. No, it's a DevOps problem. Yeah. Okay. So in architecture, Docker is a bit lightweight. Why? Because it shares the operating system. So we have a host operating system and a guest operating system. This is a concept in virtual machines. So let's go to this picture. I want to delete this. So let's go to this picture and let's see what do we mean. So as we can see here, virtual machines run on a hypervisor, except the physical server, and they all have their standalone operating system. But Docker actually shares the host operating system, so this makes you only have to have one operating system, and this is what makes it lightweight. So you don't have to consume a lot of compute resources to run. You remember when we started our VMware journey, how long it took to launch a virtual machine and how long it takes to open a virtual machine on VMware. This is because of the VM architecture that it has to have its own operating system that's built on top of a hypervisor, and this hypervisor runs on the host operating system. So it has higher resource usage or compute usage. So performance, as we remember when we were using our VMware, Docker is much faster to start and it has lower resource consumption, but VMware are slower to start. And you guys remember when we were starting our Ubuntu virtual machines, and they use more resource. Okay, so portability and isolation, it's highly portable and across environments with Docker. So you can move it. It's literally a container, so you can move it. It's like a box. You can take it, hold it, and move it. This is less VM are less portable because they're tied to a certain hypervisor and hardware. Of course, VM has a strong isolation because it has its own operating system, but this has a process level isolation because it has a shared kernel. So here you can see that this is separated. How separated it is. It has its own operating system and own app. These are not. They're all shared by Docker engines, but they're separated by process. So it's a process level separation or isolation. Of course, I got this image from ResearchGate. Here you can see, so Docker containers versus virtual machines. And you can see here all of the information you need about. Okay. Okay. So we've talked about portability and isolation. Now we're going to talk about Dockers in AWS. So we have these three types of containers. We have also something that's called an ECR. We're going to talk about it. So first thing we have is ECS, then EKS. Then we're going to talk about AWS Fargate, which is the serviceless version of containers. Okay. Of course, we're going to have a full day that's called serviceless services. We're going to talk about all the service, not all, but most of the serviceless services in AWS, and we're going to understand the concept of serverless. So ECS is a container service. We also have something that's called Kubernetes. So Kubernetes is also another service. So if you open Docker, we're going to have Docker, so we can install it on Ubuntu, and we're going to do that right now. And we have Kubernetes. Here you go. So this is Kubernetes. Container orchestration services. These are third party and we can use them, as you can see here. Okay. So let's open that. Okay. So And then we have Fargate, which is the serverless service of AWS. So let's go to our next slide. And first, we're going to talk about ECS, or Elastic Container Service. It's a container orchestration. Container orchestration means that this is a manager that handles containers. So it's going to help us and simplify running, stopping, and managing container on a cluster. So a cluster is, like you can see here, I'm going to use my, let's say my, this is the cluster. So maybe you can see how many virtual machines there are here. So there's 3. Let's consider these as containers. So this is a cluster. This is another cluster. So these are clusters. It's a bunch of things, or a bunch of computers, sorry, containers. Okay. So it supports Docker containers. It runs on EC2 or Fargate. And we can have integrated with service like IAM, Identity and Access Management for security, CloudWatch for monitoring, and Route 53 for DNS services. You can also load balance it with ELB, the one we took yesterday. And then we're going to talk about automatic scaling with ECS service auto-scaling. So it also has auto-scaling services, and it has load balancing services. So EKS, or Kubernetes services, as we said, it allows us to run Kubernetes on AWS without needing to manage the control plane. So control plane is something in Kubernetes. We're not going to talk about it. Maybe we're going to do a session about Kubernetes and Docker in the future. So it's fully compatible with Kubernetes or the standards of Kubernetes. It manages the availability and scalability of Kubernetes control plane. It also integrates with services, as we said, IAM, Cloud, and Route 53. And it also supports both EC2 instances and Fargate, as well as like ECS and AKS, kind of how these two the same. Provides high availability architecture and automatic patching of the control plane. So what's the difference between ECS and AKS? Basically, it's very easy. So ECS is for Docker, sorry. And AKS is for, oh, why? Sorry. And EKS is for Kubernetes. Okay, so this is the difference between these two. They both kind of have the same features, a little bit different, but this is the main thing. So let's go to Fargate. Fargate is a serviceless compute engine for containers for both ECS and EKS. So we saw we have the ability to run it either on EC2 or Fargate. And serverless means that we don't have to manage EC2 instances, basically. So it manages it for us. So this what Fargate does. It automatically scales the compute capacity to meet your application needs. In EC2 instances, you remember we have to manually scale up to scale or add more compute resources and remove them. But in Fargate, it automatically does that for you. So this is what serverless mean. It doesn't mean there's no server behind it. You just don't manage any. فأنت مو مسؤول على البنية التحتية تاعت هذا الابلكيشن. أنت بس مسؤول عن الابلكيشن نفسه والكود اللي انت بحاجته او اللي بيحكوا له في الشغل البزنس لوجيك. Okay, so it also simplifies the process of running containers, of course, because everything that is not our business logic is handled, and we only have to like concentrate on the things we need as a business. فهذا الإشي اللي بيسهل علينا استخدام فارجيت إنه إحنا ما نهتم للبنية التحتية قد ما إحنا بنهتم للإشي اللي إحنا بدنا نحطه أو الهدف اللي إحنا بدنا نستخدمه الكود أو هذا إيش بده يحل لنا مشكلة بشكل عام. طيب ECR, it's a container registry, and this is where you store, manage, deploy Docker container images. So ECR زي نعتبره it's like GitHub for code. ECR is a GitHub for Docker images. So it integrates with ECS, EKS, and AWS Lambda. It supports image vulnerability scanning. Well, that's great. And it provides fine-grained access control with IAM, so it has security features, and it's highly available and redundant across multiple AWS regions, and it's encrypted at rest with KMS, so AWS Key Management Service. So, encrypted at rest and encrypted at transit, these are two stuff. So we're gonna talk about them maybe in the artifact and cognito, the security lecture. Okay. So we have two ECS launch types. We have EC2 and Fargate. We've talked about this. So EC2, it launched on cluster of EC2 instances, and you have to control, or you have the control over the EC2 instance, including their configuration and management. So you have more control, you have more things to handle. Fargate is the totally opposite, is you don't need to manage the underlying EC2, you just manage what you need, what the application is about. So AWS handle the infrastructure management for you. Okay, so we have load balancer and auto-scaling group configuration, kind of easy. So load balancer integration, we have two. We have the application one, which is HTTPS and advanced routing, and network load balancer, which is TCP UDP traffic. We've talked about load balancer like yesterday. So we know application load balancer works on the 7th layer, which is the application layer. And it's used for the general purpose applications, web application, and this kind of stuff. Network load balancer works on the 4th layer, which is the transport layer, and it handles TCP UDP TLS traffic, and it works for low latency critical applications. Auto-scaling group, we have two auto-scaling integration. We have service auto-scaling and cluster auto-scaling. So cluster, we said it's related to EC2, so it automatically adjusts the number of EC2 instances based on the resource requirement. And this allows the user to define scaling policies to the desired count of a task. Okay, so till now, I think the ECS and EKS service is pretty straightforward. If we do like a basic recap, we can understand that Docker helps us package everything we need in a single box, or a toolbox, if you remember. And if Tom needs this toolbox, I just give him this toolbox that has a red container that bundles everything I need into a single place. So what is bundles? What does it bundle? It bundles the code, it bundles the libraries, the runtime, or any kind of dependency in one place. So if I give this toolbox to me, it's gonna work the same as it's gonna work with Tim. Then we have 3 types of containers. We have actually 2 types of containers, Elastic Container Service and Elastic Kubernetes Service. Both of them have 2 launch types. So the ECS and EKS have either EC2 instance launch type or Fargate launch type. EC2 instance launch type, you have more control over the infrastructure, you manage the configuration and any kind of underlying infrastructure of that container. Fargate helps you manage the application on only the applications that you need. So you don't manage any kind of EC2 instances or any kind of underlying infrastructure. Okay, so also we have talked about ECR, which is a place to store and manage images, and it gives us the ability to scan vulnerabilities in that image. And it's like GitHub for images, for Docker images. Okay, so this is a quick recap. Then we have talked about load balancer integration. So it doesn't integrate with gateway load balancer. It integrates with application and network load balancer. We also have what's called a service auto-scaling and a cluster auto-scaling. So this is, it automatically adjusts the number of EC2 clusters, and this allows user to define scaling policies, so more control. Okay. So we have data volumes with EFS. Remember, EFS is a file system or elastic file system. So EFS, of course, we know it provides a file system that is elastic, scalable for AWS cloud services, and it can be used to share data volumes for AWS container, providing persistent storage. So if you remember yesterday's lecture, we've made a diagram on how, and even before yesterday, we've talked about how EFS is a great way to have persistent storage. So EFS can be mounted as data volumes in ACS tasks. Okay, so enabling multiple containers to share the same file system. So EFS also as it can mount on EC2, it can mount on ECS containers. And this gives us low latency, scalability, and high availability, and it's suitable for applications requiring shared storage. Remember the diagram we dropped. It's the same thing. Okay, so we have, I think, 4 use cases. The first one, microservice architecture. We've talked about this in the previous lecture. We didn't go in depth. I told you we're going to go in depth in our SQS lecture, SQS and SNS lecture. What does a microservice mean? But let me briefly give you an idea of what does it mean. So we have 2 applications. We have application A and application B. So these applications are dependent on each other. فعنا application A وعنا application B وهدول الاثنين بيعتمدوا على بعض اعتماد تام. فلنفترض إنه application A عم ببعت sorry, I hate this color. نفترض إنه application A sending data to application B, and A is dependent on B. So A is sending data. A is sending data to B, and B is receiving this data. So let's let's say that B unfortunately had a downtime. So let's have a yellow color. Ew. Why does this yellow look like? Okay. So let's say that B shuts down. So A is gonna keep sending these messages, and then A is gonna shut down because no one is answering him. So it's gonna keep sending all the messages. So the way to solve this bad architecture is to have the same thing. So we have application A and application B. So A and B. And we put like something in between, like a queuing message, SQS, or something like this. And A can send to the queuing message, and this thing in the middle is gonna send it to B. So if B goes down, A is gonna keep sending it to this something in between, let's say. So A is never gonna be down. So this is called a microservice architecture, and this is called a monolithic architecture. So let me write this down. So monolithic architecture. And the process of turning a monolithic architecture into a microservice, the process of turning this to this. So let me put it in, let's say yellow. I want the pencil. So the process of the yellow one, sorry. The process of doing this is called decoupling. Decoupling. Okay. So monolithic application parts in the system are dependent on each other. So if a part fails, the whole system fails. Microservices, no. If a part fails, the other parts are not affected. And the process of turning monolithic architecture into a microservice is called decoupling, or just like making the two parts not depend on each other. Okay, so we can use containers for this architecture. So are ideal for microservices as they provide isolated environments for different services. Also, batch processing, we have talked about it. So we can run batch processes, we have said, on EC2 instances using autoscaling groups, and we can use it on AWS batch. That can help, container can help us batch process jobs efficiently. Okay, so hybrid applications, we can use containers to deploy hybrid application across on-premise and cloud environments, ensuring consistency and scalability. Machine learning and data processing, so it's also gives us the environment we need for machine learning and data processing. Okay, so what's the benefits of using, of course, we've talked about like the entire lecture. So what's the benefits of AWS on Docker? No, Docker on AWS, I'm sorry. So the first thing we have is scalability. Of course, we've talked about it. It's easier to scale, especially with Fargate. It automatically does for us. So that gives us the automation. So Fargate can help us automate stuff. And Docker itself can help us automate applications. Also portability, so we can send it to each other, like the one and meet him giving these toolkit boxes. And efficiency, they're efficient. They have the like ECR, it has vulnerability scanning, so it's very efficient. Okay, so thank you guys. We have finished the theoretical lecture, thank God. So let's go and check out our AWS const. So we have opened ECS. Here it is. Or we have batch. So batch is for batch processing jobs. We also have AKS. Here you can see Elastic Kubernetes Service, but let's go back to ECS. So create a cluster. Let's see what kind of configurations we have. Yes. So here we can have the cluster name or namespace. It's okay. So service list or infrastructure, we talked about having Fargate or EC2 instances. So Fargate is serverless, as you can see here. It's easier to manage. Okay, so dev cluster. Monitoring encryption, new optional. It's okay. So create. It's that easy to create a cluster. You just put a name and choose the kind of infrastructure you want. So to make this container run, you do that in task definition. Okay, that's fine. So you do that in task definition, and this is where the tasks help you. So let's go to EC2 and install an Ubuntu open a virtual Ubuntu virtual machine. And let's try and install Docker on it. I kind of like enjoying this type of stuff. So let's go to EC2 and launch an instance as we do. Docker server, let's see. So application Ubuntu. And then we don't want any key pairs and not create a security group. Let's be environmental and launch the ones that we already have, and that's it. Just launch an instance. And guys, this is how developer works. Like if you want to install Ubuntu, you just go, or Docker, sorry, if you want to install Docker, just go on Docker website and they're gonna give you like everything you need. So here it says before you, okay, that's okay. So here we have a new type of Docker, but we don't have the newest version. So here we have the operating system. So we're gonna install, this is this, if you have it installed, please remove it. So here we can use the apt install. So this is how you get installed. So let's open our server, connect. I'll send you the code right now on the chat. So let me send you the code if someone is doing this with me. Okay, here you go. Okay. So we have connected to it. Let's first do our update. So sudo or apt update. Oh, sudo apt update. Yeah. Sudo apt get update. Okay, let's wait for it for a moment. Then we're gonna install our a few certifications and a few stuff that will make our Docker run. So paste. This is from the Docker website. So let's install this one as well. Keyrings. If you use Jenkins, you're gonna do like the same thing. Okay. Then we're gonna get this one. So it's gonna download Docker. Paste. And then we're gonna change the mood so it gives us all a read permission. So paste. Good. Now we're gonna echo this inside the here. We're gonna echo a few stuff that Docker have gave us. Okay, then we're gonna say sudo apt get update. I thought I wrote update wrong. Okay, so if we wanna now try, so this is the latest. So now if we wanna verify that Docker engine is installed, either we write, I think Docker minus minus version. Okay, Docker is not found, that's fine. But to install to verify that it is installed, we can use this. So sudo docker run hello world. Paste. Okay. Okay. Sudo docker run hello world. Oh yeah, it gave me command not found. Okay. So did I like forget anything? Let's do this again. Okay. I don't think it gave us this. That's fine. Install these things again. Okay. Paste. I'm just like copying and pasting to set up a Docker repository. Let's also try and install to the apt docker install. Yes. I should have used this one. That's fine. I'll install it after this finish. So let me send you also the script for it. Okay. So it's gonna take a few moments. Okay. Come on, guys. Come on. Yeah, it's writing a few stuff, so let me give it a moment. It's stuck. Oh my God. I think my virtual machine is stuck. Or I'm not patient enough. For a fact, I'm not. Okay. Maybe if I refresh it, everything will go. Of course, it's gonna go, but that's fine. Okay. So if I go up, I'm afraid I'm gonna install it again, so I'm not gonna install it. I'll just take this command and do it. Paste. Yes, please. Okay. Okay, so great. So now let's try running the hello world. Maybe it's gonna work. At least. It didn't. So cannot connect to Docker. Okay, so maybe sudo system cto start Docker. Okay, so let's go. I think I saw this I think. So let me check. Paste. Okay, there seems like there's a system. So let's check what's wrong. So system ctl status docker dot service as it says here. It's kind of giving me it has failed. Too quickly, failed with the result of exit code. Okay, so it exited. That's fine. We can install and use Docker later on. I think it's enough for today. I'll do it in another session because kind of today was a very long lecture and I really don't like Docker. Okay, guys. So today's lecture was about Docker. So we talked briefly about it. There's a lot to learn also in Docker, and we're gonna talk about it later on. Let me stop the recording. Okay, stop.